Hi guys, just want to show you now a little bit about fault finding, like what's really going wrong in terms of fault finding and what people really aren't understanding, right? For the 2357 and the 1605, and all this really is, right, is how to sort of explain the type of fault that you've encountered, and a logical way of explaining it to somebody like me as an assessor, right? So this is kind of like how, without giving the game away too much, about how I would explain it if I'd encountered these faults and I was doing an assessment, right? So I'm just going to pick on a few randoms and then we'll have a chat about it, right? So the first one, let's pick short circuit and or earth fault, right? First thing with this one is knowing the difference between the two. So short circuit is a CPC and a live conductor coming together, so line or neutral. And an earth fault is a line or neutral coming into contact with a CPC. So first of all, know the difference between those two faults, right? Um, so say, for example, you've got a line and a CPC touching, but you call it a short circuit, then that's wrong. You will fail that because you've incorrectly identified the type of fault, a technical sense, right? So, but let's talk about this. So let's say, for example, you've encountered a short circuit, you've put your photographic evidence in, it's tripping off, you've safely isolated it, you've done insulation resistance testing, you've got 0.00 on your meter, you've split the circuit down, found the fault, showed us the fault, re-terminated it, retested it, happy days. So that's your picture sequence. Absolutely great, right? So we know the story of the job, yeah? Now you need to explain to me. Like, so the question will be, tell me the story of the job. So I want to know, where were you? What was happening? How did you find it? How did you fix it? How did you prove your repair had been a success, right? So I'm going to explain it as I would explain it, right? So it would be something like this, right? The office received a call that one of the properties in the client portfolio had reported that the RCD had tripped out and it couldn't be reset by the client. So I turned up to the property, I conducted a risk assessment of the property, and I informed the clients of how long I thought that the job might take. I then safely isolated the consumer unit. I decided to safely isolate the whole consumer unit for the safety of myself and the people in the property. Once I'd safely isolated the consumer unit, I decided to carry out some insulation resistance testing. And upon insulation resistance testing and further investigation, circuit number 3, which was the ring final circuit for the kitchen, had a result on the test meter of 0.00 megaohms, indicating to me that the test was carried out between the line and CPC first of all, and that's the result I got. So it was indicating to me that that was an earth fault on that circuit. I broke the circuit in half. I tested one way back to the board, and it was fine. I tested it, and I had a greater than 999 on my meter, which was more than my meter could read. So I knew that side of the circuit was good. I tested it the other way, and I still had the 0.00 megaohm. So I knew the earth fault was on that leg of the ring. So I moved a couple of sockets down, opened it up, repeated the process. This time, when I tested back the other way towards the middle of the ring where I disconnected it, that the fault lied between those two sockets. I took off the socket in question, and the CPC had come out of its terminal, and it was resting on the terminal of the line conductor. So as the photo indicates, there lies the fault. What I did then was I re-terminated the CPC into the terminals. I made sure all the terminals were tight. I tightened everything back up. I connected the circuit back together. I went back to the board and I retested with my insulation resistance tester and yielded a result of greater than 999, which is more than my tester can read. So it's greater than 999 megaohms. And I was satisfied that after retesting, that my circuit was then fixed and the fault was now cleared. So I have no longer got an earth fault on that circuit. Okay, that's how I would explain it to me, right? And I'll pick another one, right? Just so you guys can sort of have an idea of what we're looking for here. We'll pick high resistance joint, right? So this one could be, let's see. So I had a client call me because there was a socket. There was some sockets in the property that there was intermittent power to it. It was going on and coming off, and they didn't think that was right. So I attended the property, I safely isolated for the safety of myself and everybody else. I carried out a risk assessment. And then this time I knew the circuit in question because the client had indicated to me which circuit it was. So therefore, I isolated that circuit and that circuit only. And it was a radial circuit. I estimated that the radial circuit was 20 meters in length and it was a 2.5 mil twin and earth circuit, right? I know the resistance per meter from my guidance note 3 is 19.51 milliohms per meter, 19.51. So I multiplied that by the length, which was 20 meters, and then I divided it by 1,000 to get my expected results for my R1 plus R2 test on that circuit. My expected results were in the region of 0.38 ohms. I tested it, the R1 plus R2, by joining the line and neutral together and testing at the end of the circuit. And lo and behold, the reading was 7.21, so it was way higher than what I was expecting. So then I opened up a couple of sockets and I noticed that there was a line conductor that was loose in one of the sockets. So I tightened it back up. I re-carried out the R1 plus R2 test at the end of the circuit. I yielded a result of 0.38 ohms, which is exactly what I calculated, and therefore ascertained that my fault was then cleared. Okay, so and that's it, guys. That's how you explain a fault in your MVQ, right? And you just do that for all the faults. So when you're preparing for your assessments, that is how you're going to explain the faults to me. I don't want anybody stumbling over it. Familiarize yourself with the faults first. There's no good coming on an assessment, right, and saying, "Oh, I don't know, Craig, I did that ages ago. I haven't got a clue, mate." Have this stuff written down, guys. Be prepared. Remember the 7 P's: prior planning and preparation prevents piss poor performance. Yeah, the 7 P's. Write it down. All your answers need to be like that. They need to be fluent. They need to be concise. You need to, where were you? What was happening? How did you find it? How did you fix it? And how did you prove your repair was a success? Retest every time. And that's the same in AM2. Okay? So that's how I'd like a fault explained. And that's how I'd like you all to explain it. So thank you very much.